Well, welcome to Chapter 3. This first section is looking at solutions of equations, and in particular just the general forms of equations, inequalities and formulas. I'm going to plunge straight into this. We've already been using linear equations. Anything that looks like this or these sorts of things, they're all linear equations. I just ask you to note that the power on the x's is always 1. Although we may not see y equals in some of these equations, but rather you'll be given a number and then have to get a solution. So generally speaking, you consider if there's x's to the power of 1, then we're dealing with a linear equation. There are some differences here. For example, this one here, we haven't come across this yet, but for the moment you can consider that to be the case. X to the power of 1 means it's a linear equation. There's a number of rules for solving linear equations. Your objective is always to end up with x equals something, or it might not be x that's used, it could be some other letter, but whatever it is, you'll end up with whatever that letter is equals some number. It could be something like this, x equals 2 or minus 7/3 or some number. It could also be x equals 3, pi g, or some other variables there as well, but it'll always be x equals. You also want all of the x's on the same side of the equal sign. So if you've got something, for example, like, let's change it to a pen. If you've got something like, 3x plus 1 equals 6x minus 2, something, the object would be to get the x's on the same side of the equation. You also want all the x's to be to the power of 1. So if you've got an x squared in there or a square root, you're going to have to deal with that. If it was an x squared, you'd deal with it by taking the square root of both sides of the equation. If it was a square root of something, you would square both sides of the equations, or whatever is appropriate, getting it back to just x. Equations can be solved. A way of thinking about it is this doing the same thing to both sides of the equation type rule. So an example here with this equation here, we want to get the x by itself, so we first of all start by adding 1 to both sides. Gets rid of that 1, moves the 1 over to this side. We then divide by 2 rather, both sides, and so on. The next equation here, subtract 1 from both sides to get to here. Then we take the square root of both sides to get down to here. Here we take 2 from both sides. Now we've got to gather the x's together, so we take 2x from both sides. That in effect gets rid of them from over here and puts them all on the one side. And then we proceed dividing both sides by 2 and so on to end up with x equals a number or some other expression. Always do the same thing to both sides. Alright, let's make a start. Exercise question 1 here. Solving the following linear equations. It asks you to check your answer in each case. How would you do that? Let's take a look at a simple equation here. We take this, first of all, I've actually put the steps in here. This is more steps than you need to write out, but I've just put every step in there for you. So here is 5. We're going to get rid of this by adding 5 to both sides. So there's the adding of 5 to there and to here. That gets rid of that, leaves you with 3x and 2x plus 6. Now I want to gather the x's on the same side, so I take 2x away from both sides like here. That gets rid of them, leaving you with 3x minus x is just x equals 6. Now the way that you check whether that's correct or not is you take the original equations here, write them down here. Now we found that x equals 6. So if I put x equals 6 here, replace the x with a 6, and I do the same thing on this side, if I've got it right, then I'm going to find that that will equal that. So we put 6 in both places. What happens? 6 times 3 is 18 minus 5 gives us 13 on this side. 6 times 2 is 12 plus 1 gives you 13 on this side. So that checks out. So x equals 6 must be correct. And it's the same for all of them. Let's just quickly down to this one here. Looks a bit ugly, but it's not too bad. Look. Here the first thing, this 2 is a problem, so we multiply both sides by 2. Now here's where you can make a mistake. multiplying both sides means multiplying everything on both sides by 2. So this has to be multiplied by 2, but also this must be multiplied by 2, and this must be multiplied by 2. So when I do that, that gets rid of the 2 here, leaving me with just 5x minus 7. This becomes 6x, this becomes 26, and we can gather those together now to give us 11x minus 7 equals 26, and from here it's much the same as we've seen previously. Again, the check is by, we came down to x equals 3, so I replace all of the x's with 3 and see what happens, and again I get both sides equal to the same number.